Welcome to lesson 4.3. Today we are going to talk about reflections. And a reflection is simply that. It's an image that is reflected over a line of reflection. So if I move my line of reflection, as we see in this animation, then the image moves. If I change the pre-image, the image also moves. So let's take a look at our notes for today. A reflection across line R, or the line of reflection, is a transformation that maps every point P to a point P prime, such that R is the perpendicular bisector of the segment P prime. In other words, a segment that contains a point to its reflected image is perpendicular to and bisected by the line of reflection. So, for example, if I was looking at this reflection right here, if I were to join A and A prime, you would notice that would create a segment that is bisected by the line of reflection, and each of these segments are of equal length. They are both 2 units long, so the line would have also bisected it. Let's actually practice doing some reflections. I have a shape here. I'd like to first reflect it over the x-axis. So my x-axis is, boom, let's do blue. My x-axis is right here, okay? And if I want to reflect over the x-axis, that means I want to take all of my points here and reflect them over such that they are the same distance away and perpendicular to this line. So if F is 1 unit away, then F prime also needs to be 1 unit away. Still want this to be blue. Okay. Also needs to be 1 unit away, and if we were to connect these two, that would make a right angle. So I is 3 units away, so I prime needs to also be 3 units away. And G is 2 units away, so we go 2 units down here. G prime. And H, 3 units away, so then we come down here for H prime, which is also 3 units away. So then we get to go through and connect our dots, and we end up with the same shape, just reflected over the x-axis. Now let's take a look at what happens if we reflect over the y-axis. Okay, let's do green this time. Okay, so here's the y-axis. If I want to reflect this shape over the y-axis, I am going to first reflect each point. F is 1 unit away from the y-axis, so I go 1 unit over. For F, I'm going to do this double prime because we're the second shape we're reflecting. G is 2 units away, so we go 2 units this way. And G double prime. H, 2 units away, 2 units away. H double prime. And I is 1 unit away, so we go 1 unit away again. I double prime. And I am now going to connect all of my points, and we get the same shape again. Now let's look at the line x equals 2. Now, the line x equals 2 is the line where x is always 2. So, that's going to be a vertical line, and that line is right here. You notice it actually runs straight through my figure. That's not going to be a problem. So, I still have to reflect everything across this line. F is 1 unit away from my purple line, so I go 1 unit to the other side to do F triple prime. G is right on the line, so I don't have to remake G because it's 0 units away, it stays 0 units away. Same thing with H. Okay. I is 1 unit away, so we do I triple prime on the other side. And then we connect the dots. And that's my reflected figure. Now let's take a look down here. I am choosing not to do number 5 because it's a little bit difficult, and upon reflection I thought y'all probably wanted a break. Let's take a look at y equals x though. This is a great reflection. First, I need to draw on the line. So the line y equals x, I'm going to do this in dark blue. Okay. The line y equals x is the line that cuts diagonally with a slope of 1, y-intercept of 0. And the way we're going to reflect these points, remember, the line we make must be, the line that joins the 2 points together must be perpendicular to this line. So basically, if this line has a slope of 1, the line that joins I and I prime must have a slope of -1. So let's see what that would look like. So if I'm going to join I with I prime, has to have a slope of -1. That means down 1 over 1, basically. It's going to have to lie on this line. And I itself is going to have to be down 1 over 1, down 1 over 1. Same distance away, right here. Okay. H is 1 unit away horizontally, so it has to be 1 unit away vertically to make H prime. And that's I prime. Again, I was 2 units away vertically, so it have to be 2 units away horizontally. If we were to join all of these, their line segments would be perpendicular bisectors, or would be bisected by this line. So now I'm going to join up my points. I don't have to rewrite G and F because they're on the line. So they don't get, well, they are reflected, but they're reflected onto themselves. And there's my shape, just as it was at the beginning. And if I wanted to, if I felt like I wanted to, I could remove that so we can really see it. Okay. All right, now let's talk about symmetry. Reflectional or line symmetry is a type of symmetry that you are all very, very familiar with. It simply means that we can draw a line somewhere on our figure where that figure would reflect onto itself. So looking here, this figure has line symmetry here because we were able to reflect this half onto itself over here. Now, let's take a look at these figures and see if they have line symmetry. And we're going to draw in the lines as we find them. So let's take a look at our first figure. All right, H. The letter H does have line symmetry. I see that it's going to have symmetry right here because I could divide it straight down the middle. And it's going to have symmetry here. We could also divide it. It's not going to have any diagonal symmetries because it won't fold up perfectly, but it has 2 lines of symmetries. I'm pretty happy with that. My hexagon, on the other hand, has a ton of lines of symmetries. We have a line here, 2, and let's connect 3, 4, and then you can also go through the middle of each side. So you should count that we get 6 lines of symmetry on this shape. It's a lot. My trapezoid only has 1 line of symmetry, directly through the center. My isosceles trapezoid. The triangle has 3 lines of symmetry. 1, 2, that was bad. Didn't quite work. Sorry, folks. 2 and 3. And the square is going to have 4. 1, 2, 3, 4. We can also have symmetry in 3 dimensions. Looking here, I have already marked in the different lines of symmetry you could have drawn on this rectangular prism to break it into symmetrical pieces. So, and we can also have rotational symmetry in a 3-dimensional figure. Objects with rotational symmetry are able to rotate around a line such that the pre-image and the image look the same. So here, No matter how I rotate this cylinder around the axis we've drawn in, it's always going to look the same. So now I would like you to complete homework 4.3.1b, that is after you've done A, and we ask you to do A, the bottom of this page down here. And thank you very much. If you have any questions, please come in to see your teacher.